Hello students, my name is Sumit Sagar Hota. I am a PMR PhD student IIT Palakkad. Today we are going to discuss lecture 4 of live discussion section, in which we will cover lecture 16 to 20 by Professor Ashok Desai IIT Kanpur of the subject Introduction to Airbreathing and Propulsion by NPTEL. This is the week 4 of the live discussion section. Okay. So in this section we will see some of the MCQs relating to the theoretical aspects and some of the problems. Okay. So this is the first question of the section. Okay, so question is, which of the following is correct? Okay, so the tip velocity they want to know. Okay, or the static tip speed. Okay, this is the question. So the answer of this question is obviously A. Okay. B tip static is equal to pi n d by 60. FPS means feet per second. This is your obviously static tip speed, where n is your RPM and d is the diameter of propeller. Okay. So the next question, what is the helical tip speed is given by which formula? Okay. Helical tip speed always the resultant of the static tip speed and the actual velocity. Okay. Okay, what does this tip helical speed means? It means the tip of propeller is following a helical path through air. Okay. Okay, the propeller has diameter of 25 unit. What will be the static tip speed of the propeller? Okay. The answer is obviously A. Okay. It's very simple. First write down what are the things given. Okay. The D is your 25 unit. N is your 1200 RPM. Solution is V is equal to pi N D by 60 is equal to pi into N is your 1200, D is your 25 divided by 60 is 1570.8 unit RPM. Okay, this is your answer. Okay, let's go to the next question. Okay. Okay, so the next question is, if a propeller is designed to have if a propeller is designed to have a 200 horsepower, then find the appropriate diameter for the propeller. Consider two blades. Okay. Okay. So write down what are the things given. P is equal to 200 horsepower. Number of blades. Number of blades is equal to 2. So diameter is equal to D at the rate 2 blade is equal to 22 into horsepower to the power 0.25. Okay, so 22 into horsepower is your 200 to the power 0.25, which is equal to 82.73 unit. Okay, so answer is your A. Let's consider we need to design a propeller engine which has 3 blades. What will be the typical value of the propeller diameter? Okay, engine is expected to produce 400 horsepower of power. Okay, so let's write down what are the things given. P is equal to 400 horsepower. Number of blades equal to 3. Okay, P is your power produced. Okay, so D at the rate for what 3 blades is equal to 18 into horsepower to the power 0.25. Okay, 18 400 0.25. Okay, 80.5 unit. Okay. Okay, so answer is A. So which among the following casting process is used in the casting of the piston? Okay. Okay. For the casting of the piston, we always need gravity die casting. Okay. 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 So pistons. So the gravity die casting is used for casting of the piston. Okay. Okay. So pistons can be prepared by two process. One is by casting. One is by forging. Okay. Which of the following is the main reason for a burnt piston? Okay, so the only reason will be the what detonation. Because of detonation there will be the excess temperature that will be produced by the fuels. Okay, and due to which there will be a chances of soot formation inside the IC engine, and due to which there will be a chances of a burnt piston. Okay, that means that the material of the piston slightly coming to the just about to come to the melting point. Okay, which is not good for the working of the IC engines. Okay. Okay, so detonation is the reason for a burnt piston. The detonation, otherwise known as pre-ignition. So the point farthest from the spark plug where hot and gas rapidly release their energy, and this is the main reason. Okay. Which material is coated on the piston to increase the service life? It's always a tin coating. Coated on the piston to increase the service life. Okay, so what it will do? Reduce possibility of scoring it is also antioxidant and tarnish resistance. Okay. So because of these advantages, these tin coatings are used on the piston to increase the service life. Piston is a dash part of IC engine. Piston is always a reciprocating part of the IC engine. So what else this piston actually do? It seals the inside portion of cylinder from the crank case using piston ring. Why the length of piston in two-stroke engine is more when compared to four-stroke engine? Okay. Okay. So the answer is A, the absence of valve mechanism. Because of absence of valve mechanism, and second, intake and exhaust of two-stroke engine have to be controlled by piston itself. So
Good
that's
evening,
an
sir.
yes.
Sir, I'm asking that which books I should follow for the like propulsion or
Uh,
gate and all.
for actually, it's not kind of one single book. Means we cannot
Okay.
tell, okay, because with different like this part person is especially from IC engine I taken from V Ganesan. Okay, so it's not exactly fixed. Some of the parts are taken from thermodynamics in previous classes, different
Yes, sir.
cycles. Okay,
Okay.
so kind of your thermodynamics, your basic now actually these are all basics, and when you go
Okay.
slowly advance, then it will be like your advanced topics of thermodynamics and fluid mechanics. All these things will be slowly it will come. Okay, so it's a kind of your mixture of everything. It's not like only one book we can actually follow. That's the thing. Okay. uh
So I was asking that these questions will come in gate.
yeah, similar questions. Mostly the questions what I am taking, maybe that is maybe you can see similar questions directly, it will be there in gate. Okay,
Okay, sir.
there is a chance, chances are there. Okay, so yeah, so these are the things. And if you solve kind of, maybe I will solve today because in this section maybe I will solve some of the maybe auto cycle or some kind of question that maybe that will be if you solve those things, it will be easy for your obviously get, it will be little easier than that this question whatever I am solving. Yeah, but it will be helpful for your gate, or if you are preparing for ESC, so these are also helpful. Okay, and more or less gate syllabus it will be okay. uh, yeah. But it's not exactly the fluid mechanics or exactly the thermodynamics. It's a kind of mixture of everything. Okay, everything system. Let's go to the next one. Okay, so what is that convex part on the piston on two-stroke engine is known as obviously a deflector. Okay, so now what is the work of this deflector? Helps in scavenging and diverts the exhaust gas to move towards the exhaust port. Using which component piston and connecting rod are connected? It's your obviously kind of pin, so its name is gun pin. Okay. So which part of the piston experience high thermal stress? So obviously that's head, okay, where the combustion will start and it will propagate, okay, towards the bottom dead center. Head, otherwise known as piston crown. So this will experience heat and high thermal stress. Okay. When the choke used in when is the choke used in the engine? Okay, especially when you see in the cold days. So in scooties, if you see, actually these choke systems are there. Okay, so yeah, we are just pulling the choke for some time, and after some time we just close the choke and then start. Then there will be a quick start. Okay, yes, especially we are actually supplying the fuel, okay, through the butterfly valve. Okay, because choke is a kind of a butterfly valve. It will open and close like a means like a how I can tell this kind of thing. This is closed and open like this. It will there. Okay, and it will actually pass the between the it will control the fuel from the venturi throat to the carburetor. Okay, so yeah, we're basically supplying the fuel to the carburetor. So
Sir, is this choke located near the fuel pump? I mean, where the fuel is stored.
uh,
Fuel
no,
pump.
actually, if you put the choke means this extra fuel will be supplied. It's it's not kind of location like in a scooty you have, right, near to the where we have key ring, there you have one plug, you can just pull the plug and after some time you just close it like that, you done, right? In bikes also I think it's
Yeah.
there also nowadays. So yeah, it's not a kind of location does not matter. When you pull that valve is in initial like this closed position. When you pull the trigger, the valve will open, means it's a kind of whole kind of structure. It's now closed. When it's open, means it's now open, so there will be enough fuel supply. And when we again next start, because there will be enough fuel inside this IC engine, so there will be enough fuel it's there, so it's immediately start. Okay, basically that's the idea of choke. Okay, we're actually providing this petrol or whatever the fuel we have. Okay, because but the thing is, the disadvantage is that in extremely cold climates, this also choke is not that much effective. We need actually really very good uh, means very highly what I can tell, highly uh, volatile fuel, okay, in cold areas. Okay, that's the reason for different region there will be different kinds of fuel. We need to mix those fuels with our normal petrol or like that, then only that time also this the choke will be basically supplying that particular fuel to the normal whatever the fuel we have. So choke having that use. Now our here in our India, just we are just whatever the bikes are there, we are just supplying the same fuel. But in other countries like Siberia, you can go, they are actually full of snows everywhere, it's there, so they are actually special fuels are there. Those are actually used for this cold start, especially we just tell this term cold start. Okay, yeah. So it's a kind of, it's especially for cars, it's actually initially there, next it's come to the scooties, bikes. Okay, okay, so the location is, the choke is a butterfly valve. Okay, located between, okay, so choke switch is there near to you, but the valve is actually basically telling us the valve location, whatever where this butterfly valve is. Even the question itself where the choke located, you have to tell, okay, this it should be near to your button or like that. If you are there, okay, choke, the location of the butterfly valve of the choke is where, then you have to tell this like it will be in the entrance to the carburetor and venturi throat. Okay. And this should be applicable for any of the cars or any of the vehicles. Okay, this is important. Okay, okay, so next question, what does this venturi in carburetor cause? Okay, so now this venturi, what it do, what it will just, okay, so eventually what it do, it will actually going to supply enough of the air. Okay, because if there will be, because if you put the stove and just turn on the choke and there will be enough fuel, but there won't be any air, that means there won't be any combustion. So that's the reason we have to maintain also this air inside this uh, carburetor. Okay, so for that the controlling device is our venturi meter. Okay, So this Venturi in carburetor control this, especially to control the reserve fuel. Okay, and it actually keeps a reserve fuel and at a constant head. So there will be a air fuel ratio between need to be maintained. Okay, it should be neither fully rich or nor fully lean. Okay, one up to stoichiometric air fuel ratio you need to maintain. Okay, that controlling device is our venturimeter inside this carburetor. Okay, so and that where this and in that location only this we are supplying this, if you see between the entrance of the carburetor and the venturi thread, in between that entrance to the carburetor and venturi thread, in between that only we are actually supplying the fuel. That means if you can assume throat is 0.2. Okay, maybe this is your entrance. Okay, and here it might be your throat. Okay, and this is your carburetor. Okay, just here maybe we are actually giving the choke. Okay, okay, so here actually you are keeping the extra fuel. Okay, so here the relief flow will be there. Okay, so this is how we actually giving extra fuel so that there will be enough combustion. Okay, and so this throat is actually controlling how much air and fuel we are going to pass through. Okay, so that's the thing. So actually we cannot tell who the flow will be in which direction. Okay, so because it the flow sometimes, because you see this flow can be this because the it's between the entrance to the carburetor. Okay, depending on the, for example, the flow is in this direction, the choke will be in the choke will be also provided here. If it will be also this direction, does not matter. Okay, whatever the flow direction might be, the choke will be always in between the carburetor and throat. Okay, okay, just yes. Focus on this question. So venturi in carburetor. What extra it will do? It will keep a reserve of fuel or constant head. Okay. So let's go to the next one. What does the okay, so okay, let's go to the next one. Where is the lean air fuel mixture needed? Okay, because lean means that we don't need that much fuel. Okay, obviously that will be a cruising operation where we don't need that much amount of fuel. Okay, while takeoff and landing of aircraft we need enough amount of fuel. Other than that we don't need that much amount of fuel. Okay, so yeah.
Sir, can you repeat what you said? Your voice was broken.
This one or this one?
Yes, sir, this one.
Yeah. I'll tell. I'm just writing first. This cruising requires the lean air fuel ratio. Okay, the reason I will tell. Okay. 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 Since the carburetor provides the engine best fuel economy. Okay. Okay. While cruising, this carburetor is actually operating on the lean condition. Okay, because because in cruising we don't need that much combustion to be happening. Okay, because in that whatever the momentum we have already generated during the takeoff, okay, in that force it will actually going to only glide in the air. Okay, so in cruising actually we don't need that much amount of fuel. The lean fuel will be actually enough to combust to for the combustion of the gas turbine engine. Okay, and so that's the reason why the carburetor also provides the engine the best fuel economy and the lean condition also. Okay, so that's the reason why the cruising does not require the your rich fuel, rather than it is required only lean fuel will be enough. It's very simple, one way you can just get to know. In your, if you know, in your bikes, if you ride the bike very fast, there will be enough amount of fuel you just waste. Okay, and again if you also put your bike in very slow speed first gear also, there are also too much fuel wastage will be there. Okay, there should be a optimum limit, like we tell economy. Okay, in 40 up to 40 kilometer per hour speed, if you just ride 30 to 40, the railway fuel economy will be good. Okay, in the similar manner, when you actually cruising condition, the carburetor actually is found that different studies are done. It's found that this carburetor actually operating very good in when there will be cruising, or there when there won't be any load on the engine. Okay, so that's the reason it's found that okay, lean fuel will be enough, or there will be less fuel and more air will be good for the operating in the cruise condition. Okay, let's go to the next one. Which of the following is the most accurate petrol injection system? Okay. So usually say port, through the port, there will be injection into the fuel of the to the petrol engine. Okay, very common injection system, port injection. Okay, so what it do in the port injection? Let's see. So what is there in the port injection? The injector spray the injector sprays the fuel into each intake port on the manifold side. Of the inlet valve. Okay, where there will be fuel supply will be there. There will be some ports will be there. Okay, like this some ports will be there, and through this the fuel will be supplied. Okay, so yeah, this is a port injection system. Yeah. 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 So okay, let's go to one question. What is the value of rate of flow of fuel if the coefficient of discharge of fuel is 0.75, area of the jet is 0.885 mm square, density of the fuel is 780 kg per meter cube, and the pressure differential causing the fuel flow is 15,000 Pascal. Okay, so let's solve it. Let's write down what are the things given. So delta P, they are telling 15,000 Pascal. The CD value given, coefficient of discharge 0.75. Density of the fuel is 780 kg per meter cube. Area of the jet is 0.885 mm square. Is equal to 0.885 into 10 to the power minus 6 meter square. Okay. We need to find the rate of flow of fuel. Okay, that means QF we need to find out. Okay. So let's go to the solution. So QF is equal to CT into area of the jet into square root of 2 into rho F into delta P. Okay, this is the formula of your discharge. You should remember all these formulas. Okay, so yeah, just substitute all these values and get the answer. Okay, so it will be 3.101 into 10 to the power minus 3 kg per second, which is equal to 3.1 gram per second. Yeah, the options are not little bit not matching, but if you just assume it, the option will be 3.21 gram per second. So your answer is A. Okay, maybe they taken some, they didn't consider some of the decimal places. Maybe we consider all the decimal places. This is the correct answer, 3.1. Yeah, if you don't consider all decimal, then maybe 3.21 will be your answer. Okay. Okay, let's go to the next one. The thermal efficiency of petrol and gas engine is about this. This values you should remember. Okay. Answer is obviously B, 30%. Efficiency of petrol and gas engine is only 30%, but the diesel engine having very good efficiency, nearly 70%. Okay, these values you should remember. Okay, so next question.
Sir,
Yes,
sir, can you show the previous slide once?
previous slide. Okay.
Okay, sir. Okay.
So next question. It is assumed that all the processes of an standard air standard cycles are dash. Okay. The question itself, they given the answer. If you read the question carefully, the answer is already written. They just written their standard. Standard means always the ideal condition, which always means it's reversible. Okay. Okay. Like this, if you don't know anything, also you can just get the answer. Okay. I didn't study what's written, but the standard cycle written means it's reversible. That's it. Still, just write down what is the question. All the processes of an air standard cycle is reversible. If it is only written air cycle, okay, then it's may not be reversible. Okay, so this, because it's an air standard cycle, then it will be a hint that they are giving. Okay, and it's written so what they can, what you can assume. Okay, these are the two hints to get this option. Okay. The thermal efficiency of a standard Otto cycle for a compression ratio of 5.5 will be dash. So if you know the formula of the efficiency of Otto cycle, then only you can do this question, otherwise you can't do this question. Okay, the efficiency of Otto cycle is 1 minus 1 by r to the power gamma minus 1. Okay, so now in the thermal efficiency Otto cycle, nothing is given in the question. Okay, so standard, they written what standard. So the standard Otto cycle always is a what? Is a standard means it's a air standard cycle. Okay. Okay. Which means gamma is equal to gamma of air, which is equal to what? 1.4. The ratio of specific heats. Okay. And R is your compression ratio, which is given 5.5. Okay. Just substitute and find. Okay, if you solve it, you will get some 0.4943, which is equal to 49.43 percentage. The nearest answer will be your 50%. Okay. Which is your answer B. Okay. The efficiency of an Otto cycle is increased by increasing dash. So basically the efficiency of the Otto cycle, you know, in the from the previous question, it depends on only on the what? Compression ratio. By increasing, decreasing, don't need to study anything. See where written compression ratio. Okay, B option compression ratio. So this is the answer. That's it. No need to see anything. Okay. Still we'll just see how it affects. Okay, this is easy question. Maybe the question might not be that much easy. Maybe they can frame one question. The compression ratio will increase, the compression ratio will decrease, or its compression ratio remains constant. If they will frame that kind of question, then it will be difficult. Okay, so yeah, just simply write down the formula of compression ratio. So they are telling the efficiency of cycle is increased. That means efficiency, they are telling it will increase. Okay, so if the efficiency will increase, okay, by increasing what? Okay, so now if you can see, if I will increase this value, okay, if I will increase this value, that means this value, whatever this total value will be, what it is going to what? Decrease. Okay, and because it's 1 by something is there, that means which is equal to what? It will be less than 1. Okay, so if it is less than 1 and this is already 1 and it's less than 1 and again it's decreasing. Okay, it's also decreasing. That means this whole total value will be what? Will go into what? Increase. And that's what they are talking about. Okay, so that means by increasing the compression ratio, our efficiency of Otto cycle going to increase. Okay, okay, and that's the relation. can tell directly proportional. Okay, means for remembering purpose. Okay, compression is directly proportional to your efficiency of the Otto cycle. So the Otto cycle consists of what? So if you know the each cycle, each processes of the Otto cycle, then only you can answer this question. Yes, it's very simple. Just need to draw the Otto cycle, especially the TS diagram or PV diagram, whatever you want. I am drawing the TS diagram. Okay, so this is your 1. Always give the direction 1, 2, 3, 4. Okay, Otto cycle is a constant volume cycle. Okay, constant volume heat addition and constant volume heat rejection. So here volume is always constant. Okay, and there will be a 1 to 2 process, there will be compression work, and there will be 3 to 4 process where there will be turbine work. Okay, and here constant volume heat addition, here constant volume heat rejection. Okay, so this is your Otto cycle. Okay, so if you see the option C, okay, there will be 2 constant volume process and 2 constant entropy process, because you see 1 to 2 entropy S is constant and 3 to 4 also entropy is also constant. Okay, the answer is C. Okay. Okay, so this Otto cycle is also known as the constant volume cycle, because there is 2 constant volume heat addition and heat rejection. So these Otto cycles are also known as the constant volume cycle. So due to okay. Okay, diesel engine has a compression ratio of what? Okay, diesel engine never have a this much low. Obviously, this is not a option. Maybe this two B and C will be a confusion. 25 to 40 is extremely high. This we won't expect in any kind of engine, whatever till now available. Okay, till date available. It will be either 10 to 15 or 16 to 20. This is actually little confusing question. Okay, so maybe we really know it's actually in the order of nearly more than 15. Okay. R means your compression ratio. Okay. So now this is also the similar question. In diesel cycle, heat addition takes place at a dash. Okay, so let's draw the cycle. Okay, so here actually it will be pressure is your constant. Here it will be your compression work. Here it will be your turbine work. Then there will be your constant pressure heat addition and constant pressure heat rejection. Okay. Okay, so your answer of this question is B.
Sir, can this cycle be called as Background cycle?
Huh?
Can this cycle be called as Background cycle?
Yes, yes. Same. Yeah, that's correct.
Okay.
Rijal cycle, otherwise known as also Brayton cycle. Okay, that's good. Mostly we know it as actually Brayton cycle, but sometimes we actually, when they ask the question, they will tell you this is a diesel cycle. Okay, to confuse you. Okay, it's also Brayton cycle. Okay. This diesel engine is invented by this Brayton. Okay, and he invented this cycle, and the cycle as per his name is written as Brayton cycle. Okay, there's two cycle. One is diesel and one is the Brayton. These two scientists only made this initial inventions of diesel cycles. Okay. So what is the combustion in spark ignition engine? Okay. So there's two types of engine obviously, no, one is your SI engine, one is your CI engine. Okay. So always remember, in any kind of SI engine there will be always a homogeneous combustion. Okay. And when there will be a CI engine, it will be always a heterogeneous combustion. That means the fuel and the oxidizer does not mix properly. Okay. So this is your spark ignition. This is your compressor ignition. It's basically due to the fuel density. Okay, that's the reason why it's homogeneous or heterogeneous. It is not asked, but if it is asked, this is the reason. Okay, why homogeneous and heterogeneous? That's the reason is the density of diesel fuel is higher than the your petrol fuel. Okay, it's not going to mix properly. Okay, that's the reason some people are in the petrol engine bikes. If you put diesel engine, it won't work. Okay, there will be knocking. Okay, so yeah, so let's do the one question. Yeah. This this is a kind of your, if means this kind of questions can be asked in any kind of mm, uh, maybe in lengthy question like mains exam, IES mains. So something like that. This kinds of questions can be asked. Okay, and if you just see one part, will can be asked in your gate exam. Okay, any one part they want to ask, the question will be this big, or maybe they will ask only one. Okay, but anyway you have to solve everything. Okay, so let's start. So let's start out of the things given. This is a four cylinder four cylinder 4-stroke petrol engine. Okay, so then it's given the compression ratio is 6, so R is equal to 6, diameter given 10 centimeter. Yeah. Petrol engine has a bore diameter of 10 centimeter, so it's equal to 0.1 meter. Then length of the stroke 15 centimeter given, is equal to 0.15 meter. Okay, again one more thing given, the engine develops 25 kilowatt of indicated power. Okay. So indicated power IP is your 25 kilowatt. Okay, next given your RPM 2000. Then so it's a 4-stroke engine. Okay, so number of strokes is equal to N is equal to capital N by 2, RPM by 2. Okay, if you're 2-stroke, it won't be only is same as your N. Okay, this is for your 4-stroke, because for 4-stroke engine, for a 4-stroke to complete 4-stroke, there will be how much rotation of the engine? There will be 2 rotation. Okay, of your this crankshaft. Okay, for 2-stroke engine there will be only 1 rotation. Okay, so that's what it's written here. Okay. Next it's asked the thermal efficiency 30%, which is 0.3, so which will be what, 2000 by 2, your 1000 RPM.
So for 4-stroke we are doing N by 2. Then for
For
2-stroke it will be N.
it will be N. Okay, just means whatever is there, just put it. Okay, because for 4-stroke engine, this piston will move top dead center to bottom dead center, again top dead center to bottom, because there is 4 cycles, so there is compression, expansion, all these things are there, right? So then this rotation of this crankshaft will be 2 times. Okay, but for the 2-stroke engine, there will be only in 1 rotation, all the cycles will be going to complete. Okay, so that's the reason we are just, so it will be exactly the N. Okay, so to find is obviously a Otto cycle. Okay, so just Otto cycle efficiency we need to find. Next is the mean indicated pressure. Okay, so mean indicated pressure PMI. Okay, okay. And third will be your fuel consumption in per hour basis, kg per hour. Okay, so these are the things we need to find out. Okay, so let's start solving. So if it is a lengthy kind of question, so you have to write down like this, how I am writing, what are the things given, what are the things you need to find. Okay, and then what are the assumptions. Obviously in a kind of your gate exam kind of scenario, no need to do all these things, directly put the formulas and get the answer. Okay, no need to write down all these things. But yeah, if you have a practice in all these things, then it will be, all this writing is in your mind when you are writing the paper. Okay, so I am assuming the petrol engine works on air standard cycle, because it's in practical scenario it won't work. Okay, there will be some losses. Okay, and I am assuming the gamma is also 1.4. Actually it should not be 1.4, it can be changed 1.39, 1.41 like that. Okay, so let's start the solution. first question, the efficiency of the Otto cycle will be 1 minus 1 by r to the power gamma minus 1 is equal to 1 minus 1 by, we have the value of r as what, 6. Okay, just need to
Sir, I have a doubt.
yes.
Like, why we solve for ideal purposes? Because after all, we have to go to industry and solve for the real.
Yes, the thing is in the the thing is, you see, in the for this kind of question, they should actually given the values, right? They are not giving anything, like if it is operating, what is the if it is operating on air standard or how it's operating, it does not mention. And if it is industry, in what condition it will operate, that also does not mention. Okay, so for that condition they have to give the gamma value. Without gamma value we cannot find out the efficiency. Okay, so if they are giving the condition, they should give the values. If they didn't give the value, that means we have to assume that there is no other option you can solve. Okay, but yes, you have to write down that you assume this value, then only it's good. Okay, and most of the question they always think that you know all these things, so you have to assume, you just assume all these things and you do. It's like that. Okay, if you're operating in any industry, they are obviously the gamma value will be already known. People already done the experiments, everything they done, they already have the value of those engines. Okay, so yeah, so yeah, here it will be 1.4 minus 1, and if you solve it, you will get some 0.511 or 51.1% efficiency. Okay, so yeah, next question is the so for the finding this indicated pressure, we know very well the indicated power formula we know. Okay, so we know the indicated power, IP is equal to PMI or indicated pressure into L, length of the stroke, area of the this piston. Okay, cross sectional area, N, number of rotation, and K, how much cylinders you have. Okay, divided by 60. Okay, this is the formula. Okay, so yeah, we have everything given. Indicated power also mentioned, 25 into 10 to the power 3. So PMI into your L value, stroke length we have 0.15, area is your, because bore diameter given 10 centimeter, which is 0.1 meter, which is your the area, then we can find out pi by 4 d square, because it is a circular cross section of the cylinder. We are assuming it is a cross circular. Okay, actually it's not also properly circular. Okay, so N will be, we already found that it's 1000, and there is it is a 4-cylinder engine, so it's already mentioned in the question, so we just multiply with 4. Okay, divided by 60. Okay, to convert it into from hour to per second. Okay, so if you solve, you will get your PMI will be 318.3 kilopascal. If you convert into bar, it will be 3.183 bar. Okay, mostly the units we use as bar. Okay, in industrial aspect. Okay, this is your answer, and this is your answer. Okay. Or it will be in kilopascal. Okay, kilopascal and megapascals. Okay, so the last bit is your fuel consumption per hour. Okay, so it's very simple. If you find the efficiency, thermal efficiency is equal to indicated power divided by mass flow rate into the calorific value of the fuel. Okay, so we need actually m dot f is equal to the indicated power divided by efficiency, thermal efficiency into calorific value. Okay, just substitute all these things. Okay, 25 divided by, this is kilowatt, it's 30% efficiency, 0.3 into 42 into 10 to the power 3 kilojoule per kg. Both are in kilojoule, so you just directly got it. Okay, So yeah, if solve, we just get m dot f as 1.984 10 to the power minus 3 kg per second. Okay, if we just convert it into hour, okay, by multiplying with 3600, okay, with this value we will get 7.14 kg per hour. Okay, this is also your answer. Okay. We just solve one more question. Okay. Okay. This is also a question, but it's actually completely okay. Just quickly solve this question. Okay, this is actually each bit is a kind of your small question can be asked in your NPTEL exam, in your GATE exam, okay, in IAS prelims. All these are small bits are important. Okay, I club together mostly all types of question what can be asked from this, especially these lectures. Okay, so let's solve this one. This is your last question. Quickly solve it. Okay, so okay, so the given is, this is a single cylinder 4-stroke diesel engine. Previously this is a petrol, this is a now a diesel engine. Okay, because it's a 4-stroke, so n will be equal to capital N by 2, which is equal to 250 by 2, which is equal to 125 rpm. Okay, it's 250 given. Okay, so number of cylinders means k is equal to 1. Okay, okay, and then diameter given 15 centimeter, which is 0.15 meter. Then the W brake will be given also. Okay, so yes, here it's given brake load. Okay, this is also very important term. The brake load, W brake is your 392.4 Newton. Okay, the length of the stroke given 25 centimeter, which is 0.25 meter. Okay, then it's also given indicator diagram, area of the indicator diagram given. Okay, AI is 6 centimeter square, which is 6 into 10 to the power 4 meter square. Okay, and indicator length of the indicator diagram is small l is equal to 9 centimeter. Okay, what is the spring constant given? Spring constant, you can see here it's written the spring constant. Okay, 7.5 bar per centimeter. Bar per centimeter. Okay. And what else? Bore, stroke, everything we have. Brake specific fuel consumption. Okay. Just write in some, always written in this short format. Brake specific fuel consumption. Okay. 0.24 kg per kilowatt hour. Okay. So all things given, we just written. Okay. Now one more thing, so like some of the things like calorific value we just didn't write. So the calorific value is 42,000 kilojoule per kg. Diameter of the brake rope diameter.
Sir, are all these assignment questions?
Huh?
Are all these assignment questions?
No. I actually should not solve this assignment question. Okay, I am not advised to solve. Whatever things I will solve, it may be helpful in your assignment and it will be helpful in your exams and in your understanding of the course.
Okay.
Okay, assignment question you have to only solve. Okay. Okay.
Okay.
So D rope will be. It's actually not assignment questions. I actually seen it's not that much difficult. Okay. But the thing is, if you to understand this course, you need to know all these questions. Actually, what this course is capable of. Okay, what level of questions or whatever level of understanding you should know about this course, especially in practical applications. Okay. So for that, I am actually solving this. This is actually all practical application based questions. Okay, and which will be more helpful in your future. Okay, if you are having any job in industry or wherever, or for you are preparing for any exams. Okay, so like UPSC. So yeah, all these are helpful. Okay, we need to find brake power. Okay, indicated mean effective pressure. Okay, and indicated power and mechanical efficiency, thermal efficiency. Okay, so let's quickly start the solution. Okay, so first one term here we just get to know, we called it as effective brake radius. Okay, I don't know it's covered or not, but yeah, you just remember this term, how it's defined. Okay, effective brake radius. Okay. Is D brake. When this rope, all these things are given, then you have to do this. Okay, D brake plus diameter of the brake plus diameter of the rope divided by 2. Okay. All things given, we have 70 plus 3.5 divided by 2, which is your 36.75 centimeter is equal to 0.3675 meter. Okay, so let's go to the next one. Okay, next find out the torque. T is equal to load into effective brake radius. Okay, so which is equal to W brake into R brake. Okay, we already have these two values, 392.4 already given in the question, and this actually now we just recently find out. Okay, 0.3675 meter. Okay, which gives rise to your torque value will be what? 144.2 Newton meter. Now, okay, now these are the two first of all, these two things are required to find out all these. Find out the brake power. Okay, so what is your brake power? the brake power is your brake power is equal to P is equal to 2 pi nt by 60,000 in kilowatt. Okay, if you are converting into kilowatt, so 2 pi n is your obviously given what 250 rpm. Okay, so it's given 250 rpm, so 2 pi 250 into t, we have 144.2. okay, for this we only calculate the torque. Okay, divided by 60,000. okay, so your brake power is 3.775 kilowatt. Next, find out here indicated mean effective pressure, okay, which is PMI is equal to A by L into C. Okay, A you have, okay, AI is your 6 centimeter square, L you have also 9 centimeter, okay, and C value you have also what 7.5. okay, this is your spring constant C. okay, let it be AI. okay, so 6 by 9 into 7.5 equal to, directly converted into bar, 5 bar or 500 kilopascal, because the unit is in bar per centimeter. okay, so don't change anything to meter. okay, otherwise it will be a problem. okay, let's see the units. okay, so let's go to the next one, which is our indicated power. So indicated power is equal to mean effective pressure into length of the stroke, area of the cylinder, into number of rotation, into number of cylinder, divided by 60. We have all the values of substitute. okay. Area of your pi by 4 into d, bore diameter, okay, into 125 into 1. okay. The single cylinder engine divided by 60. If you solve, you will get your indicated power as 4.6 kilowatt, because this is in already in kilopascal. okay, so we just whatever you solve and you will get in kilowatt. okay, so next we find out the mechanical efficiency. Mechanical efficiency always defined as the brake power by indicated power. okay, brake power you have 3.775 kilowatt, indicated power we found 4.6 kilowatt. okay, let's substitute 3.775 by 4.6, 0.82 or 82%. okay, your combustion efficiency, which is a very good combustion efficiency. okay, okay, so now next we find out the m dot f. okay, sorry, fifth one. okay, so we just know that brake specific fuel consumption is equal to m dot f by brake power. okay, you see we need to, okay, so now we have, okay, we need to find out this thermal efficiency. okay, we have brake power, we have indicated mean effective pressure, indicated power, mechanical efficiency. Now we need to find out the thermal efficiency. okay, so we just have brake specific fuel consumption given. okay, from here we just calculate the m dot f. okay, 0.25 is equal to m dot f by brake power, we already have 3.775. okay, from here we just get the m dot f as 2.516 into 10 to the power minus 4 kg per second. Okay. Yeah. So now we know also the formula of thermal efficiency is your what indicated power divided by m dot f into cv. Okay, we have everything, just substitute and find, which is here 4.6 divided by m dot f. We now find 2.516 10 to the power minus 4 into calorific value 42,000. Okay, this is your 0.435 or 43.5%. Okay. Okay, so this is the answer. So these are all answers. Okay. Okay. So we just end the section with this. Okay. Thank you very much for attending the section. If you have any doubt, you can ask in my YouTube channel comment section. So my channel name is my name Sumit Sagar Hota. Okay, we'll meet again next week for the
Sir,
next
I'm
week.
asking.
Yes, any question?
Okay, I'm asking one thing that. Yes, sir.
Yes.
Sir, is this course sufficient for gate propulsion part?
uh yes, my means gate also, actually this much syllabus are also not required. Okay, it's actually too much, if I will tell. And in gate, in some of the part of combustion, it's there. Okay, it's not only propulsion will be there in gate, there will be also combustion will be there, right? The reaction, especially the reaction like this one, methane combustion will be there, and there will be, they will ask what is the air fuel ratio, what is the overall equivalence ratio. All these questions are also common, right? Those part you have to go through. Okay, but for propulsion part, I think most of the especially for here, especially this question is basically from your IC engine, right? It's not also propulsion. Okay, and in propulsion in gate, very less question is going to ask. Okay, maybe one or two or max, like that. Okay, especially some here it will be kind of your somewhat your IC engine will be there, little bit your thermodynamics will be there, some of your fluid mechanics or advanced thermodynamics. All these things are actually clubbed together, and these courses are actually made. Okay, so yeah, it's actually, I cannot tell that it's purely from propulsion all the question will be here. Okay, that's actually unfair to tell. Okay, but yeah, your understanding of basics will be here cleared for the, especially from this course. Okay, so that I can tell. Okay, but anyway, you have to study. Actually, if you are preparing for your gate exam, means you have to mostly focus on in what area the questions are asked more, rather than focusing on only for 1 mark. If you are focusing on to study, I'll study for 1 mark, then it's actually completely no use, right? So it's like that.
Yes.
But yeah, you can learn something, that's I can assure. Okay, and it will not only useful for your gate, it might be helpful in other exams, especially for EAC. This question whatever I taken, that's mostly your EAC mains, you can see this question. Okay, it's directly some year is exactly this question is asked. Okay, directly EAC main question I am just solving. Okay, and you know very well, if you read the previous year's questions of GATE, you very well know the mostly the previous year of EAC are also sometimes asked in the GATE exams. That you are, if you know it. Okay, so yeah, it's kind of overall idea you will get. I can tell that. Okay, if there is any other question you can ask, you
Thank
can
you, sir.
ask me. Okay, okay. Thank you, and good night. We'll meet next week. Okay, 6 to 8. Okay, thank you.